our host. There we go.
There
Now
it
we're
is.
recording.
Very official.
Perfect. Thank you for asking. That was perfect. See, we're already in synergy and working together. So it looks like our numbers are starting to level off. So I think we're going to get going. Brian, are you ready?
I was born ready, Eric. Come on.
Good morning, afternoon, evening. My name is Eric, and I'm here with my buddy Brian. We're here to talk about live hacking in your AWS workloads using Snyk and Atlassian tools. Quick introduction so you know where we're coming from. My name is Eric Smalling. I am a senior developer advocate here at Snyk, and I'm a software developer background. I've been doing enterprise development for, 30 years with a specialization lately in containers, cloud native, the DevOps kind of things like that. I've got a lot of experience in CI/CD as well. I'm a Docker captain and certified in Kubernetes and all those good things. Brian, introduce yourself.
Hi, everyone. I'm Brian Clark. I'm also a developer advocate at Snyk. My background is in web development for the most part. More recently, the majority of that experience has been around focusing on JavaScript and Node.js, doing full stack web development in particular. And yeah, plenty of enterprise experience as well. And just lots of fun building out web related things, tools and websites and so forth. But yeah, excited to talk about security today and hopefully help everybody learn a bit more about application security from a web developer perspective, along with Eric's side of things.
Awesome. And thank you again for all the hellos. There's so many scrolled by, I can't say hi to everybody. I did see a Texas. Kunal, I am also in Texas. I am in North Texas in the Dallas-Fort Worth area. So welcome to the talk. So let's hit our agendas. We already did our introductions. We're already partway into this. So first, we're going to talk a bit about application risk profiles, kind of level set as to what are the things you need to watch out for security-wise, about your security posture with your application, both from code and libraries and containers and cloud native kind of points of view. And then we're going to get out of the slides. We're not going to do a lot of slides today. We're going to get right into some demonstrations where Brian and I are going to show you some actual vulnerability exploitation. We're going to show what can happen, how it can be done, how easy or hard it might be. And I like doing that because as developers, we don't often get to see, it's all theoretical. So we get to see, get to show you what it looks like. Then we're going to talk about, how could you prevent it? What are proactive exploit prevention tools and processes and things you can be doing to protect yourself? Then we'll wrap up. Now we will try to field Q&A as we go. If we have any left over toward the end, we'll try to field that at the end. And like as Brian is chatting right away, feel free to put them in the Q&A section, and we'll get to them as we can. So let's talk about applications first. So the modern applications, waterfall pretty much is the thing of the past. We're all doing agile development and CI/CD. We're trying to get things, velocity up, get small incremental updates out to the customers as fast as we can. The tools and processes you use for that need to keep up with that velocity, and that includes your security scanning tools. Historically, a lot of the application security scanning were very slow or had very strict restrictions on where you could run them. You could only run them in, say, certain CI agents, or they had licensing, only let you run a couple copies of them at a time. And that really doesn't scale well with a high velocity. So we want to, we're going to show you how, our tools are able to get the scanning done quickly and in all areas of your life cycle. The other thing to talk about as well is that your source code, my dog is barking in the background, sorry. The source code that you write, the custom code, really, it makes up about 10 to 20% of what you actually ship, because the other 80 to 90% is generally open source libraries nowadays. And this isn't new. This has been kind of the trend over the last decade plus. But the thing to realize about that is that of the artifact you ship, that's how big the stuff that you didn't write is. And 80% of the vulnerabilities in there aren't necessarily in the library that you asked for. Let's say I'm writing something and I include package XYZ123. It has transitive dependencies and pulls in other artifacts that it's like a big tree, and it expands out. 80% of the vulnerabilities we see are in those indirect dependencies. then we get into, the fact that a lot, if not most, enterprise software is now getting deployed in containers. And that adds a whole nother aspect to your, challenges, right? You're now dealing with operating system level things like Linux distributions and packages, apt-gets or RPM, Yum, APK, all these packages you're installing, and file system permissions, network permissions, all these things that we are aware of as developers, but often we had other teams that would do for us and kind of mandate on us. You're going to use this version of Linux and we're going to give you these packages and they're going to take care of it. Now that's squarely on our shoulders because Docker files and Kubernetes YAML and things like that often are right alongside our code. And then finally, we have infrastructure as code. We've gotten to where now compute, storage, network, the clusters that we run our stuff on is defined as code as well in tools like Terraform, CloudFormation, and Kubernetes really fits in this as well. The YAML that defines how your application is glued together in an orchestrator like Kubernetes, that's code as well. The NSA has said that the #1 vulnerability in the cloud right now is misconfiguration of infrastructure as code type configurations. So that being said, last slide for this part. So when you look at your software delivery lifecycle, we often view it as a pipeline. This is a very simplistic one with a bunch of logos thrown on it, but you see the purple boxes with our little patch logo. These are the areas where security can be applied in a general sense. And we can start all the way from the left where you have your source code, where you want to be able to scan right on your workstation, right from your command line or your IDE, whether that be VS Code or JetBrains tools, or even if you're in Cloud9 on AWS using that, you want to be able to scan from there. We have integrations with all of those, as well as Docker Desktop and Docker CE for scanning right inside of Docker. Then we move into the actual pipelines, and whether you're using AWS code pipeline, commit and build, or you're using the Atlassian Bitbucket suite, or a number of other tools, GitHub Actions, Circle CI, Jenkins, you name it. We have integrations with all sorts of tools like that to help you test, fix, and monitor your code and container images and infrastructure as code files at all the stages along the line. And finally, all the way into production, where, as far as AWS is concerned, we have integrations with things like Lambda, where we can, if you're doing serverless, we can look at your functions and detect when they change. EKS and Fargate, we can do some monitoring. Everything I'm talking about today, by the way, from Snyk's point of view, we're just talking about the free tier stuff, by the way. There's nothing here that's in the paid tier, except I'm going to put that asterisk that EKS Kubernetes live monitoring, that is a paid tier tool. I'm not really going to get into that because I'm DevRel and I don't have to sell anything. Finally, you've got ECS, ECR. The images you push to ECR, we can integrate directly into there and scan for vulnerabilities right off, as they come in. One of the cool things that we do as well, both with the code commits into your Git repositories and into your registries, is we can, if you want to use it, we have active monitoring in the free tool that will by default, every 24 hours, will look at code and or images that were pushed, might not even have changed, but if new vulnerabilities come up, we'll let you know, so that you might be clean today, no vulnerabilities found, but tomorrow somebody finds a new vulnerability, and if you're impacted, you need to know that, and we're able to show you that. That's enough with the slides. So I'm going to stop sharing screen. I'm going to throw over to Brian, where he's going to. Brian, do you want me to show the Bitbucket piece first, or do you want to take it?
Yeah, if you don't mind showing that really briefly, that'd be great.
That.
I'm kind of jumping off from there. And just while you're setting that up, we had a couple comments in the chat to just throw your way. Jamie made the joke because you mentioned that NSA had the #1 issue being misconfiguration, and then Jamie had #2 is Java with the current events going on, jokingly. Well done, Jamie.
Oh, it hurts. I'm a Java developer from the day, but I will talk a little bit about the Log4Stash later when we get into my side of the demonstrations, because I am doing a Java-based demonstration. It's so fresh. I haven't gotten to where I'm comfortable doing an exploit demonstration with it, but we'll talk about it, and I'll talk about some of the, at least my opinions and some of the things that we can do here at Snyk and just you can do in general to protect against it. The first part we're going to show you right now is our, we've got an application that is deployed into Bitbucket, or at least the source code chunk is deployed in Bitbucket, and we're using Bitbucket pipelines to automate, build, and scan and deploy of that. Brian's going to get into some of those details in a second, but we have, just to show the pipeline quickly, you can see it has multiple stages. It ends up pushing it to ECR and then to EK, and it's deploying it in EKS. So here's our ECR repositories. You can see this one, we've only deployed one so far today. I cleaned up our demo here. And then if I go with my EKS cluster, and there's nothing custom about these. These are standard, just like you would use. And here is my cluster, and it's got the nodes. I'm not going to dig too far into that. And you can see here is our wonderful Goof To Do app running, and is running out on AWS in my EKS cluster. So Brian,
Excellent.
let's show us what you can do with that.
Let me share my screen here. Switch over here. So as part of all this, while Eric and I are showing you, I'm going to walk through this demo and setting everything up. There's also a workshop that coincides with it that you should be able to get a link to, and you can try out and get hands-on practice yourself. So please don't feel like you have to take notes or keep track of everything that we're doing here. The assumption I'm going to go under, though, is kind of what Eric just showed you. You've set up a Bitbucket account already. You've set up all these prerequisites in the getting started part of the module. You've already kind of gotten squared away and you're ready to go. For the sake of time, we're jumping into that. So what I'm going to show is Eric's been so gracious to give me access to his Bitbucket account. So we're going to have a lot of fun with that. Thank you, Eric, for trusting us. Not really the best decision you've made today, but I'll have access to that so that I can then import the project into my Snyk account and start monitoring it and being alerted to any security issues that we need to look out for. And in particular, what I'm going to be focused on is, like I shared at the beginning of the session, I have a web development background doing full stack web development with a focus on Node and JavaScript. And so what's interesting to me is understanding how I, as an application developer, can be a little bit more security minded. How can I be on top of making sure that I am providing the safest experience for my users, for my business, for the apps and systems that I'm building with the technologies that I'm using. So with that, I'm going to jump over. I have a Snyk account already set up, and I'm signed in with that as well. And I need to add a new project. I want to add the project that Eric just showed you that's been deployed to AWS. It's over in Bitbucket. So there's this add project button in the top right-hand corner. And I'm going to use this. This is the simplest way that I think, but there's other ways that you can also plug in Snyk for your repositories that you will have up on Bitbucket. So I click on that, and it'll pick up that I'm signed in already. And then I have my own account under Bitbucket. But like I mentioned before, Eric gave us the keys to the domain over here. So we're going to grab that project that he has for this workshop, the patterns library. And I'm going to choose, once I check that box, that lets Snyk know that I want to add that selected repository. So I'm going to click on that big green button in the top right-hand corner, and that will add it to the project. Now, before we go into all the juicy details of what Snyk finds wrong with this application, which, by the way, it's intentionally vulnerable for demonstration purposes, I want to show you, because I think it's really important as developers, myself included, like it was important to understand what it is that we need to defend against, because we can constantly be told and get that, rammed to us, that messaging of like, hey, you need to worry about security. You need to worry about security. But at the end of the day, a lot of times your performance is graded on what value are you adding to the project? What value you're adding to the business? Are you adding new features and functionality? Are you completing those tickets in your agile process that you might be having, right? And security isn't always at the forefront of everybody's mind, especially, depending on who's the stakeholders in your company, your org, and so forth. So while that messaging is often sent to us, it's not necessarily always prioritized. But with tools like this and the things that we're going to see today, you can see how you still can prioritize that, and very simply and easily, it doesn't get in the way and slow you down from doing what you need to do, which is you're building new features, you're building stuff. You want to focus on that. So that said, let's get into what it looks like to actually, we're gonna put our hacker hats on. Hold on a second. You gotta have the hoodie on, right? I should turn all the lights off and get a nice little spotlight on me, make it really dark, and then just start bringing up a terminal that has a bunch of letters going across it, right? Just kidding. So our hacker hats are on. We're going to take a look at this vulnerable application that's part of Eric's project here. So I'm going to switch over to, I use VS Code for my development. This is the application here. It's called Goof. It's a web application that is just a to-do app, which you kind of saw the UI of it there briefly, that was deployed on AWS from what Eric shared earlier. So in particular, when it comes to Node and JavaScript-based projects, we use an ecosystem, for those that maybe aren't familiar, that's called NPM. And we define our dependencies through package.json. And NPM is quite, well, in general, web development in Node.js, there is a package for everything, which is sometimes tends to be the thing that folks that come from other languages and ecosystems to poke fun at. So it's both a blessing and a curse in disguise sometimes. A blessing in the sense that there's a lot of things that we can use, and it gives us a lot of options as developers, so we don't have to rewrite the wheel, so to speak. But at the same time, it's also introducing a lot of lines of code that we didn't write ourselves. And with that, when you aren't the one that's writing that code, there's potential more what we call surface area that provides attackers or people that are looking to do malicious things, gives them more opportunities to poke holes in our apps and see how they can take advantage of that and start doing bad things, right? So in any case, but that can be found in any ecosystem too. But in any case, here's all the packages that this project depends upon. But in particular, I want to show you this one called Marked. And what's great about this library is it provides to me, as a developer of this application, the ability to allow my users to enter in details using markdown syntax. And so maybe some of you are familiar with that, some of you aren't. But essentially, there's a lot of shorthand that allows you to do kind of styling to your text. You can add links a little bit more easily instead of having to write like HTML code. You can use just brackets and asterisks and things like that of that nature. So that's what Marked is doing. It's providing the capability for my users to use markdown syntax to enter in details, okay? So when we're running that app, I'm just gonna run it locally right now before we, actually, you know what? Let's go to the one that Eric deployed to show that that is indeed vulnerable here. That's my localhost one. Here's the one that's up in AWS. So to demonstrate what that marked functionality is providing to us, I can do things like, I need to brush my teeth. I promise I did, but it's not like it matters anyway, since we're all remote right now. Brush my teeth, and I add that to this to-do list. Very simple, straightforward. But maybe I want to be able to italicize something like, no, really brush teeth now, right? Actually, I did that wrong. I don't even know my own markdown. You know what? It might be double underscore. Really brush teeth now. There we go. That emphasized it a little bit. All right, so that's what Markdown does. But in particular, as an attacker, I'm looking at this and I'm like, ooh, this is an area where, let's see, I can provide input into here, and maybe I can do something that changes the behavior of this application now. Maybe I can circumvent some of the security measures that they might have in place to take advantage of the system. So I know Markdown. I can create links like AWS, and enter, or I don't know what's an Amazon.com, so HTTP. Make sure you put the S in there. Amazon.com, for instance, right? I enter that in, and then that creates a link that is now clickable that can open up a new tab into that URL. So with that in mind, I might want to see what else can I do in here. So I want to test as an attacker, can I inject some HTML code, an HTML tag up for script, and then try to trigger the alert box to go off from here, /script. No, I can't, but you can see it didn't quite exactly take it the way I entered it. So what's happening here is it looks like the library is doing what we call sanitization, input sanitization. And what that means is it searches for keywords that are deemed bad, that are trying to do malicious activities, and just completely removes them from the input and leaves the rest intact. So that's what sanitization is about. So I'm starting to notice that as an attacker, that this is what this library is doing, or this app rather, is doing. to help prevent security issues. So let's see if we can maybe try some more things out. Maybe you didn't know that you can actually just use the JavaScript keyword here to try and run some JavaScript code directly in the app. So let's see if that works. That's another avenue we could take as an attacker. I entered that and oh, all right. So didn't quite work, but we're seeing some different results now, right? And so maybe they're keying off of that JavaScript keyword, or what I would do as an attacker now is like, maybe I'd explore the app further and understand what libraries might be used. And in particular, maybe I realize that this library is using marked, and I start looking at the source code of it. And I see here that, well, one, let me take a step back, right? So as a developer that's using this marked library, one typical way we do that in Node is we require it, assign it to a variable, and then we get it set up, right? And for marked, you look at the typical documentation of it, you just assign it to something like app.locals marked equals marked. But then if you're doing your due diligence, you're going to see if they have any security options to enable, to turn on, to make sure that it's as safe as possible. So one thing to note here as well is lots of these, while it's great to have open source libraries that help us out as developers, they don't always necessarily turn security features on by default. So unless you're actively looking for those options, you may not know in this case that you need to turn on sanitization for the marked library through the set options function. That's kind of concerning there, right? Like it would be ideally turned on by default, but in this case, they wanted to allow the users of this library to have control over whether that's enabled or not. Okay, but I'm going to show you that we can still, even with that in mind, bypass the sanitization techniques and logic that they have, even though it's there, right? Like they're doing their best. And so I learned that maybe I learned that this library is being used, and I look at the source code of it. In particular, we can see that the renderer, when there's a link, if the sanitization option is turned on, it's doing all this stuff to try and prevent bad things from happening. So I see it's doing URI component decoding. It's doing some escaping or trying to unescape some of the URL that's there. It's replacing some regex. Anybody know regex in the chat? You can help me out here. This is like looking for a keyword or something, I think, and globally. And then setting to lowercase. But then also down here, we can see it's looking for that JavaScript colon keyword and just set, if that's true, then just return nothing, remove it out, right? So maybe I can bypass that by replacing the semicolon with something different, like the URL encoded version of a semicolon. So if I go back to my site here and do test2, and I say JavaScript, and if I recall correctly, it's ampersand pound 58 semicolon and then alert one, close that. No, still not quite the deal. So rather than try and go through every possible iteration, you get the idea. An attacker is going to try and circumvent these things and keep trying new things that would help them bypass some of the security measures that are in place. So to see the exact vulnerability that we could, or exact input that creates the possibility to bypass this, I'm going to copy and paste it really quick, and then we'll talk through it. So we have the HTML, the markdown link text. We still have the JavaScript keyword, and then we do the URL or HTML encoded semicolon. But then we add this keyword. And for those of you that maybe aren't familiar, in JavaScript, that's a valid keyword in JavaScript. You could use this, you could use window, you could use document. The idea here, though, the key with all this, no pun intended, is that it's going to cause that logic to be bypassed because it's looking for JavaScript colon, and that's it. And it's going to pick up that there's this keyword, which is also valid JavaScript, so it won't break anything. And it allows us to then execute this JavaScript function, which is the alert. And then we can close out the parentheses on that using that encoded version of it. And let's hit enter to enter that in. Oh, we got something there. And then I click on the link and it does work. So there we go. We have a cross-site scripting vulnerability through this marked library. This is a third-party dependency that we have, even with the security features turned on. So you might be wondering, how the heck am I going to be able to, I use a lot of different libraries in my project. How am I going to find out about these vulnerabilities and be alerted to them? And that is where Snyk comes in. So trouble is the Zoom menu is blocking my tabs. Okay, so here we go. This is where I want to be. So you remember before I added the project, Eric's project, into my Snyk account. So once it was added there, it scanned and it scanned all the different ways that this app and system's working. So it sees I'm using package.json for my web app, and it's using some Docker file and some other things. And so now it's alerting me to all the different vulnerabilities it found based on my dependencies, at least for the package.json one. Now, I'm not going to go into detail just yet on how we can go about fixing these. I'm going to leave that up for later. For now, we saw how this all works from a web app perspective, but what about the Docker side? What about the container side of things? And that's where Eric's going to take over now. I'm going to stop sharing, and he's going to show you some of the things that we need to be concerned about from that angle for this application.
Okay, get my screen back ready to go here.
And Pawan, thank you for that tip on hiding the floating meeting controls.
Okay, so let me get back over to Bitbucket here. So let's talk about container vulnerabilities real quick. And I'm going to jump over to a different repository because I'm not a Node.js person. I never really got into JavaScript, and it's a failing, but we have a Java version of this. And let me show you the Docker file for this. So let me set the scenario, what we're looking at here. Let's imagine we're at a company that has a legacy JEE app. And a couple of years ago, we decided to containerize it, put it in an orchestrator. And we crafted this Docker file. Let me grow the font a little here. That you can see is pretty simple. It's a multi-stage build. If you're not familiar with that, it means that you can have multiple from lines, and the final one is the one that actually produces the image that goes to production, or it goes to your, you deploy, you push and deploy. Our first one simply does a Maven 3 based build. We create our artifacts, and then we go from the second one. We start from the official Tomcat image at 8.5.21, which for anyone who knows Tomcat and Java, that's hella old. I'm not going to lie with you there. But the idea here is that we lifted and shifted this thing into containers because it's a legacy app. We're in maintenance mode with this thing. We fix it occasionally. And that's the version of Tomcat we're on when we did it. And if it ain't broke, don't fix it. That's the attitude my organization has. My fictional organization. So all we're doing in this is setting up a couple configs and then copying artifacts that we built in the first over, and then the official Tomcat image brings it up and starts it. So let's go take a look at it. So here it is running out on my EKS cluster. Honestly, not that interested in the app really in this case, because like I said, that's a really old version of Tomcat. If I go to the root context, you can see there's 8.5.21. There's the sample stuff. Now, if the demo gods are going to be good to me today, let's go in here. I'm going to set up something real quick. Put on my black hat hacker hat and talk about vulnerabilities in Tomcat. So if you are aware of it, there is an Apache Tomcat page that documents all of the security fixes they put in with each, for each release, and all the different vulnerabilities that they're targeting here. If I scroll down and look through, there's denial of service attacks, there's request mix-ups, there's all sorts of fun stuff in here. But the one I'm looking for is scrolling. Gosh, there's a lot of them. Here we go. There's a remote code execution vulnerability. And we're all heavily familiar with RCEs this weekend because of the log4share one. And I'll talk about that more in a moment. But this one is one that exists in the Tomcat's utils jar. And if I were to dig into the CDE, we could look into it and see, here's the details about, how to get it and all the mix of things. But what's more interesting is there's an exploit database entry on this, which has proof of concept code. And this is simply a Python script that will do a check to see if a given HTTP endpoint is vulnerable. And it has a proof of concept hack for it. And so I've copied that. Get back over to my shell. Make sure my aliases got set up correctly. I think they did. So I'm going to run check. And come on. Of course, it's going to work. Got to work because we're in live demo and something's hanging. That's never good.
Sending good vibes your way, man.
Yes, please. While that's hanging, I'm going to open another shell and make sure that the right host name got grabbed. Moment. Fill that. That should be 79. Oh, it might not have been. Let me do a quick little change. Nothing's going to stop me. I will hack this server. Oops. If I type the correct URL, I'll hack it. Yes. Something is stopping me. So tell you what we're going to do. We're going to shift gears. And we're going to start up a local Kubernetes cluster. Sorry about this, folks. Actually, you know what I'm going to do? Fun. This is working. Let me make sure I didn't actually put the exploit out there and the script just didn't screw up. It did. Okay, so something's up with my script, but keep going here. So what I see here is a POC JSP. That was not there, I guarantee you, a moment ago. What it is just a bunch of A's. That's not very nefarious, really. But the fact that I was able to push a JSP up to a flat Tomcat server, honestly, my app didn't even have to be deployed. It's the Tomcat server that has the vulnerability in it. So now I'm going to go back and get my shell back up here. And we're going to run the other side of this proof of concept. And I'm going to change POC to PWN. Now I get this nice little form. And what can I do in here? I can pretty much run any Linux command I want. It's running right alongside the Tomcat JVM in the container that it's running on. So I just pulled the environmental variables first just to see kind of what I can see. I can see there's a Kubernetes port number. This happens to be the IP address of the Kubernetes control plane, the API server, as it, from the point of view of the pod. That tells me a few things. It tells me I'm running in a container, most likely, in a Kubernetes cluster. Let's see, who am I? Oh, I'm root. That's a bonus. That's nice to have. Let's see if we have curl access to things. Google.com. And I got a redirect. That's a good sign. That tells me likely I connected to Google. I have curl on the box as well. That's nice. Let's do one other thing. Let me try to touch a file somewhere I shouldn't really be able to. I really shouldn't, hopefully shouldn't be able to touch files anywhere. But let's now look at ls ltr etc. Whole directory. And sure enough, I created a file under ets. So at this point, honestly, most scripts or hackers or anything, they're just going to start curling in their own stuff and start building their beachhead to expand their exploit from here. Maybe I'll install software on here that modifies your JVM. Maybe I'll put a Bitcoin miner on here and start using all the CPU I can. Because I'm root and I have write access, I can probably, yes, I have access to the Debian apt repos. I can install anything from there that I want to do. Now, honestly, right now, hopefully your production tripwires are going off and things are unexpected network access, unexpected file system things are going off, and you're going to catch this reactively, but it would be better to catch it proactively. And before we get to that, and some of those mechanisms, I'm going to jump back to Brian, who's going to show that kind of a thing for his application. And just a time check, Brian, we are at 11 or 12:36 your time. You're muted. You're still muted. Oh no, I will put words in Brian's mouth as he speaks. I'm
So here's the thing. I went and I did what I forgot who it was in chat that told me to hide the menu controls, but then that's where I would mute and unmute. So I was like, all right. So how do we be more proactive about these vulnerabilities that are in our apps? Well, one way we can go about doing this in particular, I'm going to look at the package JSON results that Snyk provided to me when it scanned my application. And we know that this vulnerability that I was demonstrating earlier is called through the marked library that I'm depending upon. And in particular, it's this one. And to show you some more about this, like if I wanted to learn more about the details of how this was reported and just get a little bit more of the story behind this too, which is a great benefit that I found as a developer personally, to understand these things and learn more about it. If I click on this link here, it brings me to the write-up that Snyk has provided, the how critical or the severity level rather that this vulnerability has been deemed for this library. I can understand exactly how it's exploited, who created it. So credit to Matt Austin, when it was disclosed. But part of the story here that's also interesting when it comes to open source is if we look at the PR as well, we can see that Matt Austin had raised this PR with the changes that were needed, along with some tests to help show that it's fixing the problem here for this library. But one thing to note, if you look very closely, that was in May of 2015, and it didn't exactly get merged in until a year later. So it's something else to keep in mind. And one of the benefits with Snyk is that in that period of time in between, we can provide patches for the interim to help resolve that until the official change gets merged into the library directly. All right, so that said though, I looked at that and I can understand more about what's going on there, but I want to resolve this one in particular. And my personal opinion, I think it's important. Well, it'd be great to just fix all of these at once. The reality is you don't necessarily know what the implications might be on the rest of your app when you upgrade to new versions of our dependencies that we have, right? So you don't know if they're necessarily following semantic versioning very closely or not. If it's a breaking change that you have to actually upgrade to a newer version that is a breaking change, you want to test that and go through it. So I'm just going to fix this one in particular, and I want to double check on it again. It was this one, right? Yes. Yeah, that's the one. All right, so going back here. So I click on fix this vulnerability. So it's literally just click, oh, and then it fails, right? Demo gods are not on my side either, Eric. Let's go back, and I'm just going to try it again. So I'm going to search for marked, search, filter down to the one from 2015, which is this one. I'm going to click fix this vulnerability. And well, in any case, what would happen, I came prepared, is Snyk, the Snyk bot that has access to my repository. In this case, I'm showing it from GitHub, but the same thing would happen in Bitbucket for you. It'll upgrade to the patch version of the library that I need. Update my package lock JSON, which will lock me into that version. And then I can merge this PR in and then test the results to see that it's indeed working. So to demonstrate that, even though I'm not going to be able to kick that off right now, let me try one more time. Just third time's a charm, maybe. Let's completely refresh the page. I'm in the project, search for marked. I want to fix this one in particular. No, okay. Well, since I have it locally, I'll demonstrate this for you as well. So the database is running in Docker. I'm going to npm start the project really quick. I'm going to copy this vulnerability. And then I'm going to go over to the localhost version of the app. And again, demonstrate that this is still vulnerable right now. And in the meantime, you might hear my dog howling because sirens went by, and every time sirens go off, my dog loves to howl back at them. Excellent. All right, so now what I'm going to do to fix this is I'm going to just manually upgrade to the version of marked that is working and better, and I'm going to npm install the new version. Let go. Listen to the sweet tunes of my dog howling. I don't know if were you all able to pick that up, Eric? Did you hear that?
Beautifully in tune as well, yes.
Yeah, you like it, right? Get to listen to that pretty much every day. It's one of the sweetest sounds. All right, so I restarted the app. If I refresh here, oh, what? Well, I completely broke it now. Something's wrong. What did I do wrong? Wow, nothing's going right now. It was going so strong, so well. My goodness. Well, I promise you, trust me, I'm a developer. It was working. It does work. Did I do?
The fun of live.
Yeah, right. Let's double check that one more time. Me looking here to see which version. Search for marked in here. Oops. All right, got the marked library.
The good news is Melissa's dogs are singing with yours as well. So
Oh yeah, nice. Oh, version. That's wild. Well, thanks. I'm glad Melissa's dogs were howling with me here, with mine.
yes, I like doing it live. It's you get to see the fun, right?
Oh, I know why. npm install marked at that version 0.0.
Ah,
That's what I did wrong. Okay, so now if I npm start, we should be in better shape. There we go. So now if let's get that vulnerability again, or that exploit that we were doing before. If I try and enter that, well, one, you could see the one that was already in there has been completely sanitized. Like it's not visible anymore. But even if I try to enter it again as a new one, it shows up the same result. So we resolved so that patch was in there. The PR would give you the right version for the patch that has the security patch in it for that library that was detected and alerted to us, so that we can get on top of it before we start getting attacked. Like that becomes an attack vector for our application, and more people do malicious things as a result of that. In this case, it's cross-site scripting vulnerabilities. And I know it seemed like, I know before I was showing like an alert box and you're like, oh, well, what's the big deal with that, Brian? You can imagine an attacker can elaborate on this approach here and write more JavaScript code that can, for one, like when there's client-side session cookies or something like that, they can exfiltrate that sensitive data, send it over an XHR request to their own server, receive those details, and then start using that to their advantage. So that's how we could go about and proactively resolving security issues that are found in our open source libraries for a web app such as this Node app in the npm ecosystem. So kicking it back over to Eric now, who's going to show you how to do pretty much the same kind of thing, but for the container side of things. How do I?
kill your share.
Yeah, steal it because it's not able to turn off right now.
Let's see if it'll let me. It's not letting me.
All right, stop sharing. I got it.
There you go. There you go. Okay, so we are running low on time, so I'm going to talk as quickly as I can. And I've already done a couple things while we waited. So yes, I did shut that down as soon as I was done talking. Thank you for those of you wanting to go Bitmine on that. I'm sorry, I'm not going to leave that running. Also, there was a question in chat about the materials, if they're going to be made available. Yes, we have a similar workshop to what we're showing you that we'll give you the URL to that at the end, and the slides will go out via our Twitter things. We'll send it out right after this as well, and they'll be linked. Okay. So question from Jamie, how did I know Tomcat 8 was in the WAR though? So the point would be, if I had that proof of concept or something like that proof of concept script, I could be war dialing or doing what, the equivalent of that nowadays, going into looking for any hosts that are susceptible, just for some kind of just brute force, looking for anyone that is vulnerable through that script's proof of concept. So there's that. So what I've done here is let's go back in time, say I'm working on this app locally, and I want to kind of take a look at, well, how secure is this? What do I not know that I don't know about this image? I built it locally, and I've run our command. You can see at the bottom there, Snyk container test fed it the image name, and I gave it the Docker file to give it a little more metadata about how the image was built. I can scroll back in here, you can see all the vulnerabilities that it found, but the thing I find most valuable about our scanner really for images is at the very end, it will take a look at what base image you're using, and it will let you know, say, hey, you know that base image has all these vulnerabilities, like 66 critical vulnerabilities and everything else you see here. There's a minor upgrade to it. If you went to 72, which I think is the latest right now, and it's funny, every time I run this is a little different because vulnerability database changes and new things come out. This one only has 3 criticals and 3 highs. Same with if we were to upgrade to a major change to the 9.0. If I wanted to switch to a completely different version and a different distribution, I could jump down to 0 criticals. So at this point, even as a junior developer, I could go to my lead, go to my security folks and say, hey, look at what I'm seeing. This doesn't look good. And we could take a look at, okay, well, let's take a look at the minor upgrade that we can do that. We're not ready to go to 9 or 10 because we know we have some, it's old app, we don't want to test it on a new version of Tomcat just yet, but at least we can go to the latest version of 8.5. And that would reduce these criticalities. Now, you're going to have to trust me because we're running out of time. I'm not going to do a build and deploy, but it's going that will remove this this vulnerability, and we can see that from the the remediation, the release notes. That's all good and fine and dandy. That's great. It'll help us find the vulnerabilities that are known. What about 0 days? What about Log4 Stash, which now we know, and Snyk does have scanning for it now, but as last week when that was still a 0 day, no security analyst had found it yet. So how could we protect ourselves to be less vulnerable or less of a target for bad actors? And that's what I want to get into next in talking about, if I can get my cursor on, defense in depth. When dealing with containers and images, first of all, images, you want to make sure that the image you build is has a minimal footprint. You've probably heard this if you looked at image building before. You don't want to give hackers, you don't want to give them the bat to beat you over the head with. Curl shouldn't be in my app. I don't need curl. There's all sorts of stuff that top level general Tomcat image was giving me that I just don't need at runtime. There are other tags like the slim tags, or even you could get into looking at Google's distro list stuff to build up on top of that, or use maybe something else. But you want to minimize the footprint of what's in that file system to keep it from handing it to hackers to use against you. Understand how layers work, because even if you remove curl, for instance, it's still in the prior layers. And if there was another exploit that gives me root file system access, I could dig around under var and find that. That's again, not enough time to go into how that how to do that. But multi-stage builds are your friend here. You want to use those, and you want to make sure that final stage is as compact as you can make it, or use other tools. For Java, I like Jib. Jib is a great tool. It's a 100% Java OCI compliant image manufacturer plugin for Maven or Gradle, and it will build up a jar for you that is there's no shell in there. There's no shell. Well, I should say that DistroList doesn't have shells. I can't remember that they went away from DistroList. Might have a shell, but it's very minimal. Sorry. And then finally, secure supply chain. So this is like the term of the year in the CNCF world. Make sure you know where your images are coming from. You could do an entire, they have basically KubeCon with almost an entire conference on this topic, but just in general, know where your images come from and have never be deploying, like the thing that Eric built on his laptop should never be going out to a production server because you have no chain of custody. You have no idea what's in it. Only your automated auditable processes should be pushing to your registries and then out to your servers. Now, the good stuff really comes up right here. This is where you can start to really get at mitigating things like Log4 Stash. You can not run as root, first of all, so that if somebody does break in, they don't have elevated privileges in your container. If I wasn't root when I did my demonstration, I would not have been able to run apt-get. I would not have been able to write into certain file systems and folders. If I'm UID 0 in that container, I can start modifying the JVM. I can start modifying, cleaning up after myself, hiding logs, doing all sorts of stuff that I shouldn't be able to do. Privileged containers are just bad. Don't do them. And if you're writing like monitoring for your Kubernetes cluster or working on CNI plugins, maybe you need privileged containers, but you likely don't. It gives you device access on the host, you're basically root on the box. You don't do that. And in a similar vein, the Docker folks, Containerd folks, Cryo folks, they've done a good job of minimizing the Linux system capabilities that a process is giving to a good default set that's generally good. But for business applications, often we don't need any of those extra system calls. So limit your Linux capabilities down to deny them all. Try that and see if you can get the get your app to work without any additional. Most apps, many apps can run that way. There's plenty of blogs out there to talk about how to figure out strace and whatever you need to know what capabilities you need. The file system, the root file system, when you start a container up, the container engines by default put a read-write layer at the top and then does copy on write. You make it's a mutable file system. Don't do that if you can avoid it. If it was a read-only file system, I would not have been able to curl down anything. I wouldn't be able to apt-get install. All of these things add layers and layers that make it harder and harder to leverage and exploit on your system. And then finally, in Kubernetes, we have a lot of things at your disposal you can use. So secrets are great. Don't be storing credentials in your images. For good grief, don't do that. Don't put them in free text anywhere. Put them in, if you're not using some other kind of CyberArk or Vault or fill in the blank secret management system, use Kubernetes. But make sure if you're doing it, you're using RBAC to limit who can get to them, and that your cluster operators are encrypting those secrets at rest, because they aren't by default if you're just DIYing your own clusters. Use RBAC, role-based access control. Security context. These are the APIs, the settings on your pods and containers that implement many of the runtime things I just talked about. You should do that. And I'm going to skip network policy for a moment. Enforce all of this stuff with a tool like either Open Policy Agent with Gatekeeper or Kyverno. If you're on pod security policy, that's great, but it's deprecated. It's being replaced by pod security admission, which is in beta as of last week. And that's going to be the future thing. But use something to enforce the rules that you've decided for your cluster are being applied across all of your deployments. And network policy, I want to come back to that because this is an area that's kind of interesting, because I've always been a fan of setting up network policy, which is the tool that lets you specify how pods can talk to each other on the network. By default, in a Kubernetes cluster, all pods can talk to all pods. Jamie, yeah, I can't get into service mesh, but yes, there's things in service mesh you can do as well around this. But with zero trust network policy, at least, you can say no pods can talk to each other except what I explicitly allow in my allow lists. And in the case of, say, Log4Stash, where I'm oversimplifying, but the hacker is able to basically tell the application to call out to an evil LDAP server that's going to give back serializable data or something. You could say, don't allow any egress out of my application to anything but, frontier can talk to backtier can talk to database, things like that. So it's not going to solve all your problems, but it at least would make it harder. And just like back in the days when old folks like I used to put a club on our car, it's not going to stop somebody who really wants my Lamborghini. But if there's two Lamborghinis sitting next to each other, the one that has the club is probably not the one. It's this one, because they want to fight to get it. Yeah, that's a stupid example, but whatever. So last, before we handle any final questions, I just wanted to mention the fact that, excuse me, I just need some water. Snyk is an advanced technology partner with the AWS Partner Network. We're validated. We work seamlessly with AWS services. We have earned security compliance competency with service ready designations for AWS Lambda and Linux, Amazon Linux 2. We're a private offer enabled, so customers can use their existing billing mechanisms with AWS. So you can purchase Snyk along while you're burning down your AWS spend and your, what do they call it, Enterprise Development Program, EDP budget. And we also contribute, we have quick starts out there. So if you look at the Amazon Quick Start Marketplace, we have, I think, 3 out there that will deploy our stuff on top of your clusters using best practices and whatnot. The key takeaways.
Oh, Eric, I think we might have lost you, your audio. Just kind of bugged out. So the key takeaway that I got out of what Eric was talking about before is that he drives a Lamborghini. Why didn't I know this before, Eric? Well, you're not back, sir. No. Sign language. So I'm gonna have to come visit you, Eric, to get a ride in this Lamborghini. I've not been in one before. So
Are you there?
there we go. Now we hear.
Okay, this is why you should never put a smart switch, even if it's not cloud connected, on your microphone preprocessor, because somebody in your house will say, turn off everything in the house. That's a lesson I've learned, a security hardening I'm going to do. So sorry about that. Fast feedback loops, just like CI, hackers did it. They did it. Logs for share got to my microphone. You want whatever you put in place to give the same fast feedback loop that we started with CI, with your JUnits and your all that stuff. And you want that information to be proactive. You want the developer to be empowered through it, not just a big list of CVEs that, oh, here, have fun with that. It needs information to help them speak intelligently with their securities analysts and their leads and everyone else. And the comments, I got to stop looking. And practice defense in depth. So when things come up that are not known, they're 0 days, they're just, that you have at least some layers of protection between you and being exploited to hopefully save your bacon. So we do have 4 sessions this week. Today's was the December 13th one here. If you haven't registered for the other ones, please do so, or for these. You probably have if you're here. If you attend all 4, spend less. I will no longer buy Lamborghinis. There will be a spin to win swag prize for everybody that attends all 4. You'll get an email from our teams on that. And as I said, I know this is fine print here. We will send these slides out afterwards at our Twitter accounts. I'm at Eric Smalling, and Brian, you are at
_ClarkIO, Clarkio.
And these links basically are going to the top link here. A couple of people asked. We have a workstation that is very similar to what we just went through. That's available in that first link. And the rest of the stuff is all other interesting information. I think, at least many of it's container things, because I wrote the slide and I'm a container geek. So anything left in Q&A to address before we wrap? I'm sorry that was so fast at the end there. I don't have any information about direct integration with Splunk and our tool. I know we have Datadog integration. That would be a good thing to hit us up at snyk.io, which is a great place to go for your free account also. I will throw in there. But there's a little thing in the bottom right. You can ask questions like that there. The recordings of this is for this series. All of the recordings of this will be coming out at the end of when we're done. You'll get an email. They're probably all going to go to YouTube, to our Snyk account, so you can always watch that.
There's a comment about the Visual Studio Code extension. Yes, there's a Snyk plugin or extension for a lot of the different editors that are out there. The one that, I didn't demonstrate it today, but there's one for VS Code that's great that shows you vulnerabilities in your open source, but it also can scan your code using Snyk code to let you know of any possible issues, security issues there, and code quality issues. So that's super helpful. IntelliJ has a plugin.
Yep. And as I was saying, the other sessions, so people were wanting follow-up things. So we have other sessions that are going to be going. I know Stackhawk is going to be with us tomorrow. They're going to be talking about Circle CI. The final show will be, I don't know who from Snyk is doing it, but it's going to be, I think I spelled Terraform wrong. Oops, sorry. It'll be EKS Terraform related stuff. I'm going to be back on Wednesday talking with Peter from Docker, who's DevRel there. And we're going to get more into, I'm going to try to have a Log4Stash exploit example to show on Wednesday. But we're going to get more into, more in depth on some of the stuff around containers and Kubernetes. Maybe a little more interesting. And Jamie, I'll make sure I lock down so you won't be able to get as much more narrow out of my instance on Wednesday. We are at time. We're actually 2 minutes over. Sorry to keep you late. If there's anything else, Brian, you have anything else to add?
No, I just saw a question about Snyk Discord and it said that we'll probably share some more details on that in the future from the Snyk Twitter account. And yeah, just thanks everybody.
Yep. There's our, if you do want to follow us to get the slides, that's where I'll put them up on SlideShare and post them there. And thanks for following our crazy, we'll have to do something, sacrifice to the demo guys next time to not be as jerky.
Yes.
Great. Thanks, everybody. We're going to wrap. Talk to you later.
Have a good one wherever you are, and thank you for joining.